All right, so now let's go complete the square, which is again converting a quadratic expression from standard form to vertex form. And one of the reasons that we might want to convert from standard to vertex form is so that we can actually solve by the square root method, which we have done. And when we're solving by the square root method, that's when we are finding our solutions, these roots, these x-intercepts, where it crosses the x-axis at the parabola. All right, so to complete the square, I'm going to write my expression or make sure that it is written in standard form. Ax squared plus bx plus c. I'm going to take half of the b and I'm going to square it. So I kind of have this little formula, b over 2 squared. Step 3 might be the most complicated. I'm going to rewrite the expression by adding this number that I get after the bx term and then taking the same number and subtracting it after the c term. All right, and the reason that we have to do this is I have to keep the same expression. So as long as I'm adding the same number and subtracting the same number, I am equaling out at 0. Okay, so first example, let's just go to it so we can dive right in. I have x squared minus 18x plus 77. First step, write it in standard form. So x squared minus 18x plus 77, which it was in standard form. Second step, I'm going to take my b, which is negative 18. I'm only taking the number, not the x. I'm going to divide it by 2 and square it. Well, negative 18 divided by 2 is negative 9. And negative 9 squared is a positive 81. All right, so step 3, now I'm going to rewrite. Again, probably the most difficult to remember. I'm going to rewrite x squared minus 18x. So the first two terms stay the same. Then I like to do plus a blank in my parentheses plus my original c term, which was 77, minus a blank. All right, whatever goes in this plus a blank has to go, the same number has to go in the minus a blank. So I'm going to put this 81, 81, 81. Okay. Now what I'm going to do is actually factor this trinomial right here. X squared minus 18x plus 81. So I'm going to go find two numbers that I can multiply to get to 81, and those same two numbers I can add to get to a negative 18. All right, and I'm already thinking in my head, 1881 negative 9 times negative 9, or negative 9 plus negative 9. I'm going to bust up my middle term of negative 18x with negative 9x minus 9x. Drop my first term, which is x squared, and then drop my 81. I'm going to group the first pair, find the GCF of x squared and 9x, which is x. So x squared divided by x is x. Negative 9x divided by x is negative 9. I'm going to group the second pair. My GCF between negative 9x and a positive 81 is going to be a negative 9. Start my parentheses. So negative 9x divided by negative 9 is a positive x. Positive 81 divided by negative 9 is negative 9. Oh my gosh, they're the same thing. So I'm going to have x minus 9 in my first parentheses, and then a x minus 9 in my second parentheses. So I can rewrite x minus 9 times x minus 9 as x minus 9 squared. That is the whole purpose of the perfect square trinomial. Now, to find the rest of my expression, I'm going to add this 77 minus 81. All right. And we get why can't I think right now? 4. All right, so here is my vertex form. I have just converted it from standard to vertex. All right, so let's go find my vertex actually now. So I got to take the opposite of what's inside my parentheses, which is 9, okay, and my -4 stays the same. All right, and vertex form is x minus 9 squared minus 4. And to find my y-intercept, which a lot of students want to look back on, it is not -4. I got to come back up here. My y-intercept is this positive 77. So I'm going to come down here and write it as a coordinate point. 0, 77.